Okay, recording started. So yeah, if as Steve suggested, maybe people who are first time here maybe want to introduce themselves, what are they doing, what's their interest in the topic, and
Sure, I'll start. My name is Timur Friedman. I'm connecting from Paris. I'm on the faculty at Sorbonne University. And with me on this call as well is Berat Senel, who's an engineer on my team. And we're going to be presenting today EdgeNet, a platform that we've deployed. And we look forward to working with you. Thank you for having us.
I guess I will go next. This is Haishi. I work at Microsoft. I work in the office of Azure CTO. I'm an engineer. I'm here to talk about Project OWN and Dapr today. Basically, it's a distributed application model and a programming model for cloud native applications.
I guess my view, the next person I see is Brian Gartner.
Yeah, this is Brian Gartner, and I attend these every once in a while, not very regularly, but I do follow the mailing list and everything. But I did want to learn about EdgeNet today. At SUSE and stuff, I do work on edge kinds of things. I play with Kubernetes all the time. And in fact, that's why there's no webcam. My laptop's running a Kubernetes cluster. I don't want to mess with that right now. And I load my other webcam to my son for his remote access. So.
And Berat, do you want to go next?
Yeah, for sure. As Timur mentioned, I'm working as a part of Timur's team in Sorbonne University. I'm a lead developer of EdgeNet project now, so we will present EdgeNet to you today. Timur will do the introduction, and I will give the technical details to you. So.
Cool. Should we go with Yin? I think maybe we'll eventually just do everybody since it appears we only have 10 today.
Yeah, I work for FutureWay. It's related to IoT Edge and also Kubernetes stuff. So I'm regularly attending this meeting.
And Kilton, why don't you introduce yourself?
Sure. Hi, my name is Kilton Hopkins. I'm the creator of an open source project called K8s IoT Edge. It's under the Eclipse Foundation, hence the name. Now a bunch of people work on that. I'm also the co-founder of a company called EdgeWorks. I'm a regular on this group, although the last probably 4 or 5 meetings I've been either barely on or haven't been able to make it due to all this global turmoil. But yeah, I think that's about it. I'm interested in all things Edge and can go very technical. I'm really excited to see the presentations today.
Okay. I don't know if I'm pronouncing your name right, but Georgely? We're going through introductions.
Yeah, cool. Hi, my name is Gergely Csatari. I was also following this group's activity like, I know, 1 year ago, and now I'm checking back how things are working out. I'm mostly involved in the edge computing group of the OpenTech Foundation, and at this time, I think we should start to do some collaboration in terms of figuring out what are the possible test scenarios for edge cloud infrastructures, and maybe we could somehow standardize this so we can have like a set of properties what we would like to measure our infrastructure against, and we have a standardized way to do that. But let's see how far we can get. Of course, this is not my target for today. Don't be scared.
James Kirkland, why don't you go next? Oh, I think you're muted. Well, we'll move on. James, I think you're maybe muted.
I should be unmuted now.
There you go.
I was double muted. So James Kirkland from VMware. I'm a staff architect in their Kubernetes BU, doing field engineering work.
And Cindy, why don't you go? We'll just cover everybody. And
okay. Good morning, everybody. My name is Cindy Xing. So I used to work on K8s. Now I'm working in Microsoft, focusing on IoT Edge on Kubernetes. So meanwhile, I'm co-chairing with Steve and Dan on this working group. Yeah, welcome everybody.
Dion.
Yeah, hi. So I work for Red Hat, work mostly on the IoT and then lately Edge stuff as well. Yeah, one of the co-chairs of the group.
And I'm Steve Wong with VMware. I work in the Modern Apps business unit assigned to work on the Kubernetes and some other open source projects. And I've been a co-lead of this group for over a year. Last, I think, Eduardo.
Hello, everyone. My name is Eduardo. I'm a Fluent D and Fluent Bit project maintainer. I work for ARM. We used to be treasure data in the past. And well, my main interest on being involved on this group is try to see how we can improve everything that is related to data management, logging, tracing from end to end on the edge perspective.
Yeah, Eduardo, just so you know, from time to time, people have actually voiced and asked for a presentation on time series data. For people who don't know, Eduardo is behind Fluent D for a long time and a frequent speaker at conferences. So if you'd like to put yourself in for an agenda slot in this working group at a future meeting, please go for it, because I think there's a lot of interest in it. Maybe you could give a presentation on how the work you do maps into Kubernetes and IoT Edge.
Oh, thank you. Yeah, that would be great. Yeah, definitely I will do that. And also will be really interesting, guys, if you can join the Cloud Native Summit that we're going to have on next Monday. I'm not sure if you're aware about that, but like independent group of different companies, we are running a online summit where we're going to provide some project updates.
Oh, that sounds great. I wasn't aware of it. If you have access right now to the notes doc, maybe you can put a link in there. If you don't, please put it in the chat and then I'll copy it over into the agenda notes doc so that everybody gets that.
Yeah, I just sent it to at the moment.
Okay. Okay, I think we've got introductions for anybody. Did I miss anyone who wants to jump in at the last minute? Okay, let's get started. I think the first thing on the agenda was EdgeNet. So I'll let you guys go ahead and kick off. I think, Dion, you're probably the moderator, so maybe if they have a presentation, you can right-click on their name and give them authority to present. Okay, we're good. We see the deck.
Yeah, they can do it. It's good.
Great. So thank you so much for having us. As I mentioned, I'm Timur Friedman, and also on this call is Berat Senel. We're at Sorbonne University in Paris. We represent a consortium of people from a large number of institutions who've created EdgeNet as it is today. It's an effort that's been ongoing for a couple of years now. So we're the latest in a long line of global networking research infrastructures. We are maybe a little bit oddballs in this community because we do come from academia and from the research world rather than mostly from industry. There have been a series of research infrastructures, some of quite considerable size, that have been built over the years. Many of you may have heard of Planet Lab, which is one of the best known. the Seattle test bed run by Justin Kapos at NYU Tandon School. He works with us. Genie was a very big NSF-funded infrastructure. It's still operating. Fed for Fire here in Europe. Also very big multi-million-dollar infrastructure for research networking savvy. So these infrastructures have in common that they are highly distributed around the world, and they are open to public, bona fide researchers who want to do research on the public internet. So it might be network measurements, they might be people experimenting with new content distribution networks, they might be people looking at how web content looks different from different vantage points. The value of testbeds like Planet Lab and now like EdgeNet are their geographic diversity and diversity of different autonomous systems in which you find the nodes around the internet. So just to situate where we are on the edge, since we're talking about the edge, these nodes really find themselves in the wired edge. They tend not to be in operator core networks, although we do aim to deploy there. They tend not to be on wireless nodes, although we would like to deploy onto people's handsets. But basically, we're talking about people who have racked servers in their labs, university labs, research labs, corporate research labs, or people who are offering resources from a computer at home. So the EdgeNet is both a multi-provider and multi-tenant, which makes it perhaps a bit different from typical cases that you might have encountered. So each node is provided typically by a different individual or institution. We have dozens in Planet Lab. We had hundreds. We run Planet Lab Europe at Sorbonne University. We have over 200 institutions signed up, each of them providing racked servers. So each node is under the administrative control of a different individual or institution. And then we have hundreds of researchers, if you count students who access the system, thousands of people. And again, these are from many different institutions and all of them accessing separately under the authority of their individual institution. And for EdgeNet, right, so all of this is then mediated by EdgeNet Central, which is us. Forgive me for the use of the term. We hope to have a viral spread of our infrastructure. With previous infrastructures, you were talking about people installing physical boxes, rack servers for Planet Lab. People had to invest about $4,000 US dollars to buy the servers. Now, with Docker and Kubernetes, they just create a virtual machine, and in just a matter of minutes, we can install an EdgeNet node on a virtual machine. So it's very simple, very quick. And then the tremendous potential that we see for Kubernetes is that it's so widely used, so well known, Docker as well. And so people who know how to use those technologies know how to use our testbed. They just use kubectl or the Kubernetes dashboard. They use Docker containers that they may have already created in their lab for testing purposes. This is a big step forward from what we've done before on these sorts of testbeds, where really we rolled our own code. Also, it means we have a lot less code to maintain as testbed providers. So our aim our ambition is to really have this viral explosion of presence of EdgeNet nodes around the world so that we can offer to our researchers nodes that are within 5 milliseconds of wherever they happen to be, and so they could really experiment with the edge cloud at scale, you know, as compared to, say, the data center cloud, where everything is about 30 milliseconds away. Today, we have on the order of 55 nodes and growing. These nodes tend to have fairly good connectivity, but there are questions of latency and connectivity in managing a cluster at that scale. And we're certainly going to face a scaling issue as we ramp up the number of nodes. And so today, what we'd like to do is really introduce ourselves, show you what we're doing, how we're doing it. Bharat will take it from here and talking about that. And we're eager to enter into contact with others in the community who have similar issues, and we'd like to combine our efforts, share return on experience, code, and so on. We already have monthly meetings with people at Google in New York. The Measurement Lab group there has similar architecture. And so we have monthly return on experience meetings, and we're hoping to broaden that circle. So I'll leave it to Bharat now.
Hello, everybody again. This is Bharat who's speaking. I'm going to talk about what and how we have done so far and what we want to have in the next steps. So, high-level overview, we want to contribute back to the Kubernetes community, and to do so, our code could be compatible with Kubernetes. Therefore, we switched the programming language that we used in the first version of EdgeNet to Go language. So far, we use custom resource definitions that extend to Kubernetes API, and we focused on two principal themes: bringing Kubernetes into the edge computing and enabling multi-tenancy in Kubernetes. Let's have a look at how CRD works. What is our architecture for now? In EdgeNet, we use the custom resource definitions because it uses the main Kubernetes API server handling custom resources in the same way with core resources like pods and daemon sets, as you see in figure, to add new features. We have plenty of CRDs in use, such as selective deployments, authorities, users, and so on. I wanted to talk about the CRDs because I want to discuss the problems we encountered after the presentation. Two principal themes. In the first place, as Timur mentioned, when we say edge, we don't mean device edge. So the devices such as smartphones, laptops, and sensors that really have limited spare compute and data storage capability with connectivity problems. Yet, distinct from infrastructure edge, as device edge uses device resources, whereas infrastructure edge uses edge nodes, as in our scenario. Therefore, we just mean cloud-like capabilities located at the infrastructure edge. So we have established a Kubernetes edge cluster that the edge nodes are located in distributed locations by getting the benefit of a feature that makes it easy for third parties to add nodes into cluster in Kubernetes. It is a CRD that I will explain it later in this presentation. And I also want to mention that we believe that we can facilitate the procedure by delivering the VMware image or that kind of image to our users as well. A feature that EdgeNet offers to the users is selective deployment. We focused on the ability of deploying applications based on the node geolocation. that provides deploying containerized applications to a widely distributed set of nodes by choosing the nodes by their locations. This feature allows users to do so based on continents, countries, states and regions and cities, as well as polygons described using latitudes and longitudes. I also want to mention about our multi-tenancy aspect quickly. So we developed a multi-tenancy model in EdgeNet by inheriting the concepts mainly from PlantLab. Site is a physical location where PlantLab nodes are located, whereas an authority in EdgeNet is not required to provide nodes, but they can. They both own users and slices. Additionally, authorities in EdgeNet have an added feature called team to group users to give them authorization to create slices independently than authority admins. I want to mention that authorizations to use EdgeNet are handed out hierarchically so that authority admins approve local users who they know. The central admins of EdgeNet approve the establishment of authorities, and each authority having its own local admin, and that admin welcome the users to their authorities in EdgeNet. We also use CRD for email verification during authority registration and user registration. Let's focus on Kubernetes at the edge. I will explain how EdgeNet works with drawings at following slides. Today, a Kubernetes cluster consists of nodes that are all grouped together in centralized data centers and managed by one user group in general. Therefore, it's not so difficult to add nodes into the cluster. So users deploy their applications across the cluster by using a kubectl command line interface tool or dashboard. In EdgeNet, we want users to add their nodes into the EdgeNet cluster. Because of this, we made it easy to add nodes into the cluster. Additionally, although we just use Gini nodes and certain PLE nodes, in this way, each contribution of users, as you see in the slides, help us to build a much more widely distributed edge cloud by the day. Thanks to Gini and PLE, we established an edge cluster so far with the nodes that provide vantage points to users to deploy their applications. For now, we aim to reach the limit of 5,000 nodes, just to say it, in our cluster. And when we get there, we might consider participating in federation studies as well. Let's think about the use case of EdgeNet with the edge nodes located in distributed locations like Kubernetes. We have a cluster admin. And here we go. In this case, beside the cluster admin, there are authority admins who have particular namespaces and users in their authorities, technically in the authority namespaces, but I mentioned before, the authority namespace is not a workspace which users collaborate with. It means it is not allowed to deploy applications in an authority namespace, thanks to the resource cutter. There are two solutions to that. Authority admins can create teams by choosing users, maybe from different authorities. This creates a team namespace, but still it's not allowed to deploy applications through. And the participants of the team can create their slices by choosing users to deploy their applications across the cluster. So this creates a slice namespace, this controller. Second method is just a shortcut, which is creating a slice directly in the authority namespace. So I talked about that because it is related to the multi-provider scenario of EdgeNet. Our authorities also can contribute nodes into the EdgeNet cluster. In the first place, they need to install an Ubuntu or CentOS virtual machine. Second, they need to put the public key of the EdgeNet head node into that virtual machine. When the virtual machine is ready, they prepare a YML configuration file, including node name, IP address, port, SSH user, and node availability information. So that's it. The node contribution controller creates a SSH client and do install Docker, Kubernetes, and necessary packages. It also creates a kubeadm join token and run the join command remotely. Our node is ready to use. In this alpha version, we also have another feature. If a node gets crashed, it also starts a recovery procedure that contains clean installation as well to recover node from that crashed situation. Authorities also can enable or disable scheduling on nodes that they contribute to the EdgeNet cluster by updating node contribution object they created before. So after this point, I will talk about location-based node selection. The value of distributed systems is it offers us vantage points and allows us to deploy applications selectively according to locations. EdgeNet has that feature. Hereby, I will try to explain how that works. There's a custom controller without CRD that just watch the nodes. So this custom controller includes an event handler for the event types of add, update, and delete as usual to get informed about them and then run related functions. So that generates label contents and put them on if the event is editing or adding. During the creation of these labels, the controller looks for the IP address of the node. If it exists, queries maximize geolite2 database to get geolocation information according to that IP address, and then assigns the data to the labels. As you see in the slides, node labeler labeled the nodes in various levels corresponding to their city, state, region, country, continent, and latitude and longitude to be consumed by selective deployment service. But since Kubernetes has alphanumeric character restrictions, white spaces in the values are replaced by underscores and the directional abbreviations are added to the values of latitude and longitude. Here is a node in San Jose and there's a one in Paris. At this point, the selective deployment CRD joins the game. Why? Because we just want to deploy our applications in Berlin, San Francisco, and Paris. In an edge cloud scenario, users want to select nodes at particular locations for their pods by defining a subcluster. For instance, a daemon set defined as having 5 nodes in Germany and 4 nodes in France will ensure that their pods are deployed to 9 nodes that meet those criteria. Selective deployment has 5 levels, as I mentioned before. How can an EdgeNet user do that? They just need to create a YAML file as they do to create a deployment. So everything is the same with Kubernetes. I will show how it works. Selective deployment object configures daemon sets, deployments, and stateful sets that are the types of controllers to deploy applications across the cluster in Kubernetes. Nowadays, instead of creating a replica set directly, users are more likely to create a deployment that creates and manipulates replica sets. Selective deployment CRD is inspired by this method. A selective deployment can control daemon sets, deployments, and stateful sets to deploy an application based on users' desired geolocations. But how does selective deployment configure those? The controller picks up the nodes according to the selector defined by the user and configures the node affinities of controllers. Node affinity allows us to constrain which nodes the pod is eligible to schedule on based on labels on the node. Here it is. We succeeded in a deployment based on geolocations. And the next versions of selective deployment, so it is now working like a daemon set, but in the next versions of selective deployment, we'll also include a custom scheduler as well to provide feature like deployments of Kubernetes. I want to point out certain improvements that we want to have. We want to allow our providers to open their nodes to authorities, teams, and slices they desire. In this way, as an individual user, for example, me, if I contribute to the EdgeNet cluster, I can open my node only to Sorbonne University or VMware authorities in EdgeNet, so I can feel myself safe if I want. We plan to get the benefits of the admission controller to do so. And about the selective deployment, service migration in selective deployment would work properly to deploy applications automatically nearby the users regarding their locations where they interact with the application. So it might become a prototype solution for service migration in vehicular edge computing or mobile edge computing, which is based on Kubernetes. Unfortunately, because of the constraints of CRDs, there are obstacles that prevent having a better user experience, and we want to shift certain CRDs into API aggregation. So thank you so much for having us here today and for listening us. So this is it, and if you have any questions, please let us know.
Okay, thank you. We do have a second presentation, but maybe we have room for just one or two questions before we turn it over to the Microsoft people. Or we can put questions on the Edge IoT Slack on Kubernetes. And if you have any questions for us, maybe you can put them, or other group members. I think the Slack channel for the IoT Edge group would be a good place to put those.
This is Haishi. Can I just ask a quick question?
Sure.
Comment. So I think the assumption here is that the nodes are connected to the master nodes over the internet. I wonder if there's any problem about false negatives in the liveness or readiness check of Kubernetes if the node is appearing offline by spotty internet connections. The second is that about location-based node selection. Actually, I was doing a similar project with Microsoft Research and our carrier partners. I think for location-based node selection, it has great value when you have a lower granularity, probably down to the city level. But when you work with like cell towers, the reality is that the cell tower coverage is not like subdivided perfectly a geolocation, but in the same latitude and longitude, there could be multiple cell towers to choose from. So in that case, selecting nodes based on geolocation is not necessarily reliable. And some thinking is that maybe we have to proactively collect network telemetries and based on historical or predictive latency to choose different nodes. So that's just a comment I want to make. Yeah.
Okay, so could you please repeat again the first question? So I'm not sure that I understand clearly.
The first question is that I think the assumption here is that the newly joined worker nodes will talk to the master nodes over internet, right?
Yeah.
But over internet, we have like kind of unpredictable latencies and between the nodes. I think when Kubernetes master node check the liveness of the worker nodes, if you have variant latencies, there could be false negatives about nodes becoming unavailable.
Oh, Okay, I totally see your point. So we are in the very early beginning of the development. So we now start creating procedures. Any kind of experience like this you pointed out would be welcome, because to create a better procedures to recover the nodes and automatically, and also to create a service migration and location-based node selection. So it is so important, I think.
Yeah, some projects have gone with solutions or workarounds like virtual kubelets to convince the control plane that there still is a presence related to that node as a facade. But yeah, I think a lot of people have encountered problems with latency, connections dropping off and coming back, as well as some people concerned with security issues with that long communication chain going from a cloud-hosted control plane out to edge nodes, maybe over transports that aren't fully trustworthy. But that's a big topic that I don't think we're going to cover for this, but that would be a good discussion to take onto the Slack channel, I think. Just in the interest of time, I think we better switch this over to the OAM Dapr presentation.
I agree.
Only before we start, I see that Karim raised his hand, so maybe
okay.
it's a quick question.
Yeah, it's just a quick question. It's like I just wanted to add to what Iron Man said to Berat. Do you have any? It's like have you done any kind of measurement and monitoring of the platform to see whether it really performs reliably in this context of distributed infrastructure that traverses the internet? Is there any effect of the latency on the working of the infrastructure? And I don't know, that might actually create some problems, or maybe some services of Kubernetes won't work reliably in such a context. Do you have any like monitoring or benchmarking or a monitoring system that lets you actually verify this sort of things? Thank you.
Hi, Karim. So we established this cluster very newly, and we started to create our own, how can I say that, monitoring tools from migrating from the plant lab. And I think we will have this kind of measurements and data 3 or 4 months later. When we have this kind of data, I would be glad to share it with the community. So if we can keep in touch in the Slack channel, when we have this kind of data, I would be more than happy to share it with you.
Okay, great. Thank you very much.
That will be great. And we can do a follow-up presentation as well to find out about your experiences in the meantime.
Okay, Hashi, do you want to start?
Great. I think we can go the OM now.
Okay.
So should I go into my topic? How much time do I have?
Yeah, 20 minutes.
20 minutes, okay.
Some might be able to linger longer just in case it goes over.
Yeah, I'll definitely could stay longer and record everything beyond the standard finish time.
I could go fast. Can you see my screen?
Yes, we can see it.
Yeah, my network connection is kind of spotty. My wife had this great idea to buy a house in the forest. But the infrastructure here is really unstable. Okay, so today my topic is to introduce OM and Dapr. OM is the open application model, and Dapr is the distributed application runtime. So we designed these projects for cloud native applications, and our first implementations are heavily tailored towards Kubernetes. And when we actually designed these modules, we had both cloud and edge in mind. And Kubernetes being pervasive across cloud and edge actually helps the project to be applicable to both cloud and edge as well. So I thought I was new. I was going to introduce myself. I'll just skip all that. And I will skip some fundamentals discussions about why we made the project. I will just go into the...
If you don't mind afterward, if you don't mind publishing this deck by putting a link to it in the agenda notes, that'd be great, since some of those slides you skip, people might want to look at later. Thanks.
Sure. I'll share the deck. So I will just go right into the open application model. So basically the idea here is simple. We've seen a lot of developers working on Kubernetes, but in our point of view, Kubernetes is really very infrastructure heavy platform. And we really need a good modeling language for developers to model their applications instead of using Kubernetes primitives. So the idea of open application model is to create this platform agnostic modeling language for a microservice application. Essentially, an application is made up by a bunch of components, and you can define scopes or boundaries across arbitrary components. For instance, if you have a network segment, and if you have a security boundary, you can define different scopes. And you can apply different traits to different components. For instance, if you have a component that is auto-scalable, you can attach an auto-scaling trait to say, hey, this component can be auto-scaled between, let's say, 10 instances and 20 instances. So the idea is to provide the developer this modeling language so that he can describe his application in entirety and then hand it over to operations. Then the operations people take the manifest, can make different decisions. For instance, they will see the application requires an ingress or load balancer. Then the operation people can decide what kind of load balancer and what kind of ingress she will put in place for that particular deployment. And same to like auto-scaling, what kind of auto-scaling mechanism the operation wants to use. So those are separation of concerns. The developers describe the intention and the operations people make that a reality on different platforms. And there were actually numerous attempts of creating the application model before. And why we think we could do it, because there are several reasons. The first is that with the recent, well, not recent, last few years, the development of containers and the service meshes, we have the necessary abstraction language to create such a model now. Before we didn't have that. Now we can actually model each component as a black box, which is a container, and they are somehow interconnected by a service mesh. So we feel we have the necessary abstractions nowadays to actually come up with this common model. And with the popularity of Kubernetes growing, and we also hear the increasing voice and complaints about Kubernetes being too complex, not necessarily developer friendly. So there's a need to separate the Kubernetes complexity away from the developers. And that's another motivation for us to do that. And also the third one is that when we see a lot of edge computing scenario arise, people are thinking, wow, if my application, if I can dynamically deploy to different environments, maybe I want to have a cloud deployment, maybe I want to deploy to NECs when it's available, or in the disconnect mode, how I can make some of the components available on edge to provide business continuity without the internet connection. An idea of OM is to allow people to describe the application regardless how the application is hosted. Then it's up to the operation people how to adjust the deployments based on the particular environment. And I will skip the architecture details for now. So basically, the OWN project is in the co-development of Microsoft and Alibaba and also some other partners. It's up there in the open. Everybody can contribute to. We are currently at Alpha 2. It's still early stage, and we are making Alpha 3 as we speak. But the idea is to have this spec that got accepted by different people, and then there could be different implementations on different infrastructures. For instance, we are building our Microsoft Azure implementation. Alibaba has their Alibaba specific implementations, and our partners are creating their implementations. And you can imagine in the future, people can create like edge native implementations just to manage low power edge devices. So that's the idea. We are still pretty far from that, but I think that that's some direction we'd like to try on. So then there's some details about how each individual component works in the module. I think I will skip those for now. Again, they're very straightforward. There's nothing fancy about here. They should be very intuitive concepts. So I will just skip those to now. And I'd like to maybe not mention the future either, but I will switch to Dapr, which is actually more interesting in the application model itself. So the Dapr project was actually raised by Yaron Snyder, one of my colleagues. One day when we were discussing OM in the phone room, and he just mentioned maybe we can go a step further, because from the perspective of OM, each of the component or individual services is a black box, right? It's encapsulated by a container. We don't really care how that service is written. But he was saying maybe we could go a step further to provide a programming model for user to write those services. At that time, I had a lot of thoughts about that, because there was, again, numerous of attempts of creating a common programming model for distributed applications, but the success was quite limited. But then he explained his idea of to have this sidecar architecture. Basically, we chose a very non-intrusive way. We will provide common building blocks of a common distributed application, like service invocation, state management, pub/sub, etc., as a sidecar. And the application code can just consume those capabilities through a standard interface like HTTP or gRPC. There are several benefits of doing this way. The first is that the application code doesn't need to include any libraries. It doesn't need to include any Dapr libraries, right? Because everything is HTTP or gRPC endpoint. It's almost like a service-oriented architecture on the edge, right? The second benefit is that this allows us to support any programming language. I mean, not necessarily any programming language. We try to get it work for COBOL. We got it work, but we were kind of cheating a little bit. We use a HTTP library for COBOL. It's not native COBOL. But the concept, regardless, is that if a modern language can support HTTP or gRPC, then it can consume Dapr APIs. A good example of this is Rust. A lot of Rust developers, they're facing problem that they are lacking of SDKs to connect to different cloud services. For instance, as far as I know, there's no SDKs for Azure services. But if they use Dapr, they can actually bind to different Azure services. Let's say if you want to use Azure Cosmos DB as your state store, you don't need to have a Cosmos DB SDK for Rust. You can just use Dapr HTTP endpoint to say, hey, save a state with this key or read the state with this key. It's as simple as that. And then I start to believe maybe this sidecar architecture will really take off. So we started to build on the code base, and it got released a couple of months back. It was really well received by the community. We reached 5,000 stars under like 2 months or something. If you look at the GitHub star chart, our project is kind of a unicorn. It's just shoot up straight. It's different from any other open source project out there. So I think we got something there. We got something meaningful that we should keep investigating. So that's the sidecar architecture, and Dapr from day one is designed to work as a separate process instead of container. So the Dapr itself, at the moment, the binary is about 58 megabytes, and the runtime memory is about 4 megabytes. So it's really designed to run on like a lower power edge devices without containers, right? The Dapr works great on Kubernetes, it works great in containers, but it can also work as a separate process that you can attach to a main process as a sidecar. And the slides here are just showing different deployment options of Dapr. As I said, it runs as a loose process, or you can use a Dapr pod injector to inject Dapr sidecar into any pods and provide the Dapr APIs. And we also, the community is making great contributions to us. We work with SP.NET team and Microsoft, and there's also a lot of great work with Java's Spring Boot framework, and there's a Visual Studio Code extension. Someone is creating the Python SDK. So there's a lot of community contributions, and now the Dapr is able to bind to most popular cloud services you can think of. You can bind to Amazon, to Alibaba, to Google, to Azure, of course, and many third-party services like Twilio and different service providers. And the building blocks, as I mentioned, just common things we've observed that the distributed application developer would need, such as state and PubSub. But these are quite straightforward. I'll just take one as an example. Let's say the state management. Basically, when you use Dapr, we define a very simple API for you to read and write key value pairs. So you can post a list of key value pairs, and you can read a key. So that's essentially how the Dapr API is designed. So basically, we look at each individual problems the developers may face, and we define a very simple API for developers to use. And the key point of this I want to emphasize is that Dapr is incrementally adaptive, meaning when you use Dapr, you don't have to use everything from Dapr. You can, if say you only want to use state management, sure, you can just use the state API. Dapr doesn't force you to take everything from Dapr. This is rather different from other distributed frameworks in which you have to adapt everything, right? You have to adapt the programming model, the framework, the way you describe your code, the language you write your code in. So you have to buy into everything. But Dapr is very mellow and says, hey, use whatever you want. And also, we don't use any proprietary structures or data formats in the backend. So if you want to access your data store directly, you are welcome to do so. But we don't have, well, if you have to access the data stores directly, we rely on the data store itself to provide transaction scoping and concurrency, etc. Of course, in that case, you don't get what Dapr gives you in terms of concurrency assurance, but you can still do so. That's a different philosophy from other frameworks, is that we give you the tools you can use, But if you want to go beyond our tooling support, if you want to do more advanced coding, you can also do that. We don't want to try to constrain you into a small box about what the Dapr can do. And similarly, we have the same API concept for service invocation and binding. Binding is a very powerful concept, allows you to do event-driven programming. You can bind to all kinds of event sources to be triggered by different events. For instance, the ASP.NET Core guys, what they did is to integrate Dapr into ASP.NET Core. Then all of a sudden, your ASP.NET website is triggered not only by browser traffic, it can be actually triggered by all kinds of events from different event sources, which is a quite powerful use case for them. And similarly, we have output bindings that you can bind to all kinds of output bindings. And writing an output binding is really simple. For instance, Mark Risnovich, our CTO, one day he decided to write a Twilio binding. He was new to Go language, and he was able to do it under 2 hours. And of course, the pops up, the messaging-based integration, we support that. And also we have out-of-box distributed tracing. So Dapr has this concept of middleware. Because us is a sidecar sitting in your traffic flow, we can inject all kinds of middlewares into the flow without you modifying your code. For instance, we integrate with OpenCensus and in the future OpenTelemetry to inject distributed tracing automatically to your application. Your application doesn't need to do anything. Your application doesn't need to do any annotations or include any libraries. It's all configured and enabled by Dapr, and you can export to all kinds of tracing systems to collect and analyze your application. Oh, this is the Chinese version. I forgot to translate that. I should have deleted that. And Dapr also support actors and functions, which are 2 very popular programming models in distributed systems. But the problem with current functions or actor programming model is that they don't have interoperability among them. Let's say if you use AWS Lambda or you use Azure Functions, basically you need to buy into Lambda or functions, right? You can't say, I have a function using Lambda code or vice versa. But Dapr takes the approach is that we want to make actors and functions programming model choices under Dapr. So you can use Dapr to write stateless services, stateful services, actors, functions in any language, and they all work together. You can change your code to say, hey, I want to configure my code to act as actor today. Tomorrow, I may want to configure my code to act as a function. Or if I have a C# function, I want to call a Java-based function, you can totally do that with Dapr because of this sidecar architecture. And with the virtual actor pattern, I don't think I need to go into more details about this. Basically, we provide the basic, not the basic, we provide the virtual, a complete virtual actor pattern. This is pretty much comparable to Service Fabric actors or Akka actor framework. But we have a key difference is that we don't actually allocate memories for virtual actor when you access actor instance. For us, each actor instance is just a routing rule in Dapr. This allows us to create really high density actors on a single machine. One of the benchmark we did was to launch 1 million actors on a single node cluster. This is really high density because literally we don't have like a memory footprint for actor, right? Only when the actor is activated, we update the route to invoke the code, actor code. Then the state is saved to the external state store. Then there's nothing kept in the memory for the actor. So this allows us to reach really high density of virtual actors with Dapr. And the other thing we are supporting is the, of course, the functions programming model, which is that you have a compute unit, you can be triggered and bind to different event sources and write event to any destination. And this slide is just the details on how the actor failover works. This is a quite straightforward. One thing I want to mention is that, as I said, for us, that, actors are not instances. So when we failover, we are not migrating any actor instances across the node. We are just updating our routing rules. And we use an algorithm from Google. It's a flavor of consistent hashing, so that if you add more node or some node becomes unavailable, the route rules are updated to load balance across the nodes. But again, there's no reallocation happening behind the scenes. So we can actually fail over really fast. It's literally, it's a time take to compute one hash code. And that's all the content. I think I managed to finish under 20 minutes, maybe.
I think you did, but
Yeah,
if you don't mind, if you
enough.
could stay around for some questions, that would be great. I put a few questions in the chat myself, but maybe others have some as well.
Okay, let me see if I can find questions. Okay. Question always, there will be a full Kubernetes each edge location, or does it work with to work with the Kubernetes at edge node? So the OM itself, right? It's a spec. It's abstraction language to describe the application. It has no connection to Kubernetes whatsoever. But the control plane implementation, what we have is based on Kubernetes. So in that case, we do assume there's a Kubernetes cluster running somewhere. And the Alibaba, they did their implementation based on their infrastructure, which is not Kubernetes.
Okay, I think you answered my question then. So the only Kubernetes is you use it to plug into to host your control plane. But then that explains why in your slide you even showed doing an app runtime on something like an Arduino that wouldn't even host a container runtime, right?
Right, exactly. So in OM implementation, we have a separation of the control plane and the working cluster. So the control plane implementation can be based on Kubernetes, but you can schedule workload on other nodes using projects like Virtual Kubelet or some other projects.
Okay, thanks. And then my other question was about Dapr, just asking you to compare it to Knative, which maybe I'm wrong, but it takes on some of the same problems, at least from my perspective. Could you maybe just compare how they're the same or different?
Well, yeah, there are a lot of, well, they do overlap in a lot of cases because, as you said, they are kind of trying to address the similar problem domain. I think our approach is a bit different. Like I said, Dapr aims to add incremental adoption, meaning that you can just choose to use some of the Dapr functionality without actually buying the whole thing. And the
by buying the whole thing, you mean something like, say, Knative tying to Istio would be an example of them being less granular?
Right.
Okay.
Right. We are very flexible. Actually, so if you want to use Dapr with Istio, by all means. But if you want to use Istio at all, that's fine with us as well.
And does Dapr have that same perspective of OEM where you could conceivably use it with no container runtime at all and use it to host things like Arduino, or is there a minimal runtime for these applications or microservices that you'd expect?
So the Dapr has two modes. One is the container mode, which we expect to work under Kubernetes. It also runs as a separate process. Like I mentioned, it takes about 4 megs of memory when it runs as a native process. So we do envision you can run Dapr on lower power devices, but in some extreme cases, like really low power devices, maybe the sidecar architecture itself is too heavy. Probably you don't want to run a separate HTTP server on your edge devices. So for that, we are thinking in two directions. One is to make the Dapr kind of a self-hosting library that you can include in your low-edge devices. The other is to enable delegation, meaning you can actually delegate to a field gateway to acquire some of the capabilities.
Okay. How low could you go with that 4 meg package? Like, does it assume that you'd have the conventional Linux libraries available and things like SSL, or does it have requirements even below that?
I don't think we have any specific requirements because we have our own SS modules. But I have to be careful to answer that question. Actually, I'm not sure what's the low level minimum requirements.
Maybe the best thing to do, if afterward you could post links to that deck, would be great. And then maybe, given that these are open source, if you could link to the repos or the best sources to learn more after this meeting, that'd be fantastic. Same, yeah. I'd say the same thing for the EdgeNet as well.
Yeah, sure. Everything is in open. I can share all the links.
Okay, I kind of monopolized the questions here. I'll give other people a turn.
Great talk for the OM and the EdgeNet. Yeah, thanks all.
Anybody else got questions? Okay, maybe if you think of some later, we can put them in the Slack channel. And thanks, this was a great meeting. I've got a lot to think about here, and I'll follow up on the resources later.
Right.
Thank you so much.
Someone send me the Slack channel. I don't have that.
Okay.
Is it in the doc?
It is in the doc.
It's in the doc, yeah.
Okay, okay.
Or hi Jay, I can follow up with you on that.
Yeah.
Okay, thank you.
And then Eduardo, if you want to put yourself in a future agenda for FluentD, FluentBit, that'd be great too.
I think Eduardo dropped.
Maybe he dropped. Okay.
Yeah.
Well, okay. Well, unless anybody else has anything, maybe that will be a wrap for this meeting. So, bye.
Thanks, everyone. See you online.
Great.
Bye.
Bye.
Thank you.
Bye.